Hey everyone, heat is pretty much everywhere, right? It's always on the move, flowing from warmer spots to cooler ones. But how does it actually get from point A to point B? Well, it's not magic, it's physics. And today, we're going to pull back the curtain on the three invisible forces that control how heat moves and shapes our entire world.
So, to get our heads around all this, we're going to focus on something super simple, something you've probably done 1,000 times, just heating a pot of water on a stove. Believe it or not, this one simple scene has everything we need to understand the whole story. This is our lab for today.
So when you look at that pot, what do you actually see? Water getting hot? Sure. But the real question is how. It turns out there's this incredible invisible dance going on. It's a team effort between three totally different forces. And by the time we're done, you're going to see all three clear as day.
All right, first up is the most straightforward of the three. You can just think of it as heat by touch. We're talking about conduction. The definition is pretty simple, really. For conduction to work, things have to be physically touching each other. Heat energy literally flows from a hotter thing to a colder thing, but only when they're in direct contact. It's a hard and fast rule. No touching, no conduction.
Now, this is where it gets really cool when you zoom way in. At the molecular level, when you heat up a solid, its molecules get all this energy and just start vibrating like crazy. They then bump into their neighbors, which makes them start vibrating, and so on, kind of like a domino effect. But here's the key. The molecules themselves don't go anywhere. They just pass the energy along the line.
And this whole process works best in solids, like the metal of our pot. Exactly, because all those molecules are packed together so tightly. It's the reason the bottom of the pot gets hot and then that heat slowly makes its way all the way up the handle. You've definitely felt this happen, right? Well, now you know its name, conduction.
Okay, let's move on to our second force. This one is totally different. It's called convection, or as I like to call it, heat on the move. So, unlike conduction, where the energy just gets passed along, convection involves the actual movement of molecules from one place to another. This only happens in fluids, and by that I mean liquids and gases, where the molecules have the freedom to move around.
And this diagram shows it perfectly. See, the water at the very bottom of our pot gets hot from touching the metal. That's conduction, remember? But as that water heats up, it expands and gets less dense, so it starts to rise. Once it gets to the top, it cools off, gets denser again, and sinks right back down to get heated up again. This creates this amazing circular flow called a convection current.
So that rolling, churning boil you see in a pot of water, that is convection in action. You can also feel it when warm air from a heater circulates around a room. It's an incredibly powerful way to transfer heat because the material itself is physically carrying the energy around. It is literally heat on the move. All right, time for our third and final force. And this one's a little bit wild. It's radiation, which you can think of as heat's invisible rays. Now, here's the mind-bending part. Radiation doesn't need anything to travel. It doesn't need direct contact like conduction, and it doesn't need a fluid medium like convection. It's just pure energy shooting through space in the form of electromagnetic waves. It can even travel through the total emptiness of a vacuum. I mean, think about it. How does the sun's heat get all the way to us across millions of miles of empty space? That's radiation. Or what about the warmth you feel on your face from a campfire, even when you're not touching the flames? Yep, that's radiation too. It's energy traveling as invisible waves. And let's bring it right back to our kitchen stove. That glowing electric burner or that dancing gas flame is blasting out thermal radiation in every direction. You can feel that warmth on your hands when you hold them nearby, even without touching anything. And that's our third force, right there.
So let's do a quick side-by-side. Conduction, it needs direct contact, works best in solids, and it's kind of slow. Convection, it needs a fluid, a liquid or a gas, to move the heat around, and it's faster. And radiation, it needs absolutely nothing to travel through, which makes it the fastest of them all. We're talking speed of light fast. Three very different ways to move the same thing: heat.
Okay, now for the big aha moment. We've looked at these three forces one by one, but the real magic is seeing how they all work together, at the same time, in one single system. Let's look at our pot one last time, but now with our new eyes. The flame or the burner is shooting out heat through radiation. That energy hits the pot and travels up through the solid metal thanks to conduction. And then, inside the pot, the water itself starts to swirl and circulate, heating up through convection. See? All three are happening at once, in perfect harmony. And there you have it.
It's the thermal dance. The burner radiates, the pot conducts, the water convects. It's not just one thing happening. It's this beautifully coordinated system of heat transfer happening right there on your stovetop.
So the big takeaway here is that this isn't just some boring textbook stuff. These forces are happening all around you all the time. From the way your coffee cools down, to massive ocean currents, to how a greenhouse works. You now know the steps to this invisible dance. So the only question left is, where are you going to spot it next?